Well, hello everybody, Mr. G here today to talk about probably the most useful equation you're going to learn this year, Newton's second law. So when we take a look at what Newton's second law is all about, in words, we would just say if a body is acted upon by an unbalanced force, it will accelerate. That's the most general sense of Newton's second law, but really it's the formula that it's well known for. Fnet is equal to ma, where m is mass, and a is acceleration again. And I want you to note that we know that units of force are in newtons. Well, take a look at this. If we were to plug in just the units, we would have Newton is force, and that's equal to mass is in kilograms, and acceleration is in meters per second squared, which is exactly where I get this idea that 1 Newton is equal to 1 kilogram meter per second squared. So what does this tell you? Well, this tells you that all of our measurements have to be in SI units, which means all our masses are in kilograms, all our distances are in meters, all our times are in seconds. As long as you stick with that, you could never go wrong with simple plug-and-chug type questions with this equation. So let's take a look at an example. A 5 kilogram block is pushed to the right along a frictionless track with a force of 10 newtons. What is the acceleration? Well, I'm going to draw a little diagram for you, and you're going to become extremely accustomed to these next lesson. Let's say that this is our block right here. What are the forces at work here? Well, last lesson I told you about this idea of the force of gravity. And opposing the force of gravity is the normal force. Otherwise it's going to fall through the floor or magically levitate. But what's going on? It's being pushed to the right by a force of 10 newtons. Now, if you think back to Newton's second law, an unbalanced force results in an acceleration. So is there any acceleration up or down? Well, the answer is no. They're equal and opposite forces. But is there an acceleration left or right? Absolutely. There's an acceleration to the right because the only force at play here is the 10 newtons to the right. You'll notice we use the word frictionless, which means there is going to be no force in this case that opposes the motion. So we simply use the equation Fnet is equal to ma. Just a side note, make sure you write Fnet. It's going to help you down the road when you're dealing with a lot of net force type questions. A lot of people will drop the net and then they'll forget that this equation matters as well. We need to solve for a. A is equal to Fnet over m. Let's go ahead and plug in our values. 10 newtons divided by 5.0 kilograms. And you're going to end up with an acceleration of 2.0 meters per second squared. So this is the basic, most basic type of question that you're going to see using Newton's second law. Let's take a look at something equally simple. A 650 kilogram car accelerates at 4 meters per second south. What is the net force acting on it? Well, again, see, now this is why I want you to remember net force. Well, what is the net force on it? Well, it's simple. The net force is just going to be equal to mass times the acceleration of the object, which is equal to 650 kilograms times 4.0 meters per second squared to give us a final net force of 2,600 newtons. Now, force, like anything else that we deal with, is a vector, which means we have to talk about what direction it is going in. And in this case, it is traveling south. So it's really important that you include the direction when you can. Now, sometimes, again, we're going to deal with this idea that the positive sign means to the right or up, and the negative sign means to the left or down. So make sure you're very clear on what direction your forces are traveling. It's going to help you with all these questions. Okay? All right. Well, since Fnet can be determined using acceleration, you sometimes are going to need to bring in that whole unit on kinematics that you were hoping would go away. It will never go away. Let me show you an example of where it's useful. A 1,500 kilogram ice cream truck accelerates from rest to a top speed of 45 kilometers an hour in 8 seconds. What is the net force acting on the truck? Well, right away, you hear net force, so you should think Fnet is equal to ma. Do we have the mass? Yes, but do we have the acceleration? No. Which means what? Well, now we have to use kinematics. And in that case, as I said before, always write these down. V initial equals 0. Thank you at rest. V final equals 12.5 meters per second. Well, how did I get that? It's 45 kilometers an hour. You're going to divide by 3.6, or you're going to do the brute force unit conversion. So make sure you convert those units into SI. Do we know our acceleration? Well, no, we don't. Do we know the distance? Nope. And do we know the time? You bet. It was 8 seconds. So at that point, we have VF, we have VI, we don't have A, but we have T. Well, that sounds like VF equals VI plus AT. Solving for A, VF minus VI over T. Put in the values. We have 12.5 subtract 0 divided by 8 seconds, and that's going to give you an acceleration of 1.56 meters per second squared. So there's your acceleration. What was the whole point of that? Ooh, we gotta put her back here now to find our net force. So our mass is 1,500 kilograms. Our acceleration is in meters per second squared, so we're good to go there. Giving us a final value of around 2,300 newtons. Now you'll notice in a lot of these cases I tend to round or go to some sort of sig fig. In this case, there's 2 sig figs on that one. So that's what you have to go to. Okay, so there is an example of a 2-part type question. You got to find the actual kinematic quantity before you can find the net force. So always watch out for that. Okay, now when we're finding Fnet, and this is something I'm going to put a big star beside. Why am I putting a star beside it? Because you are going to get into problem after problem after problem where Fnet is going to be vital to you, especially when we get into these ideas of elevator problems or tension using systems of masses. You're going to have to deal with net force. So we'd better know how to find the net force. When the 2 forces are working together, it's simple. Think of vector addition, my friends. They're both working in the same direction. You're going to add them up. Let's use an example. Stan and Kyle are pushing a 75 kilogram Cartman, yeah right, along a frictionless ice rink. Stan pushes with 55 newtons and Kyle pushes with 45 newtons. Find Cartman's acceleration. So, if I were to draw the diagram, let's say that Cartman is one big block. Again, these 2 forces equal and opposite, so they cancel out. But what's going on? Well, we've got Stan pulling, or pushing, but we'll represent it as a push to the right of 55 newtons. And then we also have Kyle with another 45 newtons. So you can tell that they're both working together. You can imagine them just standing behind him and giving him a reef. So why am I showing arrows pulling to the right as if it's a pull? Because you don't put the arrows, the heads of arrows, into the object showing a free body diagram. So that you're going to learn about those next class, so don't worry about it. The point of this is that the net force then is going to be the force that Stan pushes with plus the force that Kyle pushes with, and that's also going to be equal to mass times acceleration. This is crucial. Fnet is equal to a bunch of forces doing stuff, which is also equal to ma. That is such a monster thing to remember. And why is that? Because now we're trying to find acceleration. Well, we're going to use this part of the equation. We've already determined that Fnet is equal to Fstan plus Fkyle, but it's also equal to mass times acceleration. So this fusion of ideas is so important going down the road. So please try your best to remember. Solving for A is equal to Fstan plus Fkyle divided by the mass. And let's plug in the values. 55 newtons plus 45 newtons divided by 75 kilograms, which is equal to 1.3 meters per second squared. Big box around it. Life is good. So that, again, is one of the more basic types. You can expect to be finding things like, oh, I don't know, the force of friction on an object based upon this Fnet type scenario. So be aware that you're just going to add the vectors, and if it's working against it, then obviously it's a subtraction, not an addition, okay? Well, that works towards this next idea, that when there's lots of forces acting on the object, I want you to remember a simple philosophy, that Fnet is equal to the winners minus the losers. Whichever forces are winning the battle, i.e. pushing harder, pulling harder, whatever, those are the ones that are going to cause the motion in that direction. And then you're going to subtract the forces that were desperately trying to push it in a different direction but didn't win. Well, what do I mean by that? Well, let's say the Batmobile exerts a force of 8.5 times 10 to the 3 newtons east, while friction pulls back on it with a force of 1,500 newtons. If it has a mass of 1,250 kilograms, what is its acceleration? Well, again, when we're talking about this idea of winners versus losers, just look at the magnitude of the values and find out which one is larger. In this case, we have 8,500 newtons exerted by the Batmobile versus 1,500 newtons exerted by friction. The Batmobile is going to win, so this object is going to be traveling east. So this bad boy up here, that's our winner. This boy down here, that's our loser. So our Fnet then is going to be the force of the Batmobile subtract the force of friction. Why the subtraction? Because they're working in opposite directions. It pulls back on it, right? So they're working against each other, not with each other like in the previous example. And like the other question, it's still equal to mass times acceleration. Fnet is always equal to ma, but it's also equal to the sum of these different forces, okay? So what do we need now? We need to solve for acceleration. Acceleration is just equal to F bat minus the force of friction divided by the mass. I'm going to go up here to make life simpler. Let's put in our values. A is equal to 8,500 newtons, subtract 1,500 newtons, divided by 1,250 kilograms. And that's going to give us our final value of 5.6 meters per second squared. Acceleration is a vector, so we better know where we're going. The winner was traveling east. Therefore, this bad boy must also be traveling east. So, there we go, my friends. Newton's second law. It is an incredibly simplistic equation that has stood the test of time for years and years, and there are some more difficult types of questions that will involve kinematics, and there's some even more difficult types of questions that involve really conceptualizing what this net force is all about. So, practice, 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 and we'll talk to you again. Good luck.